Hello. Welcome to my channel. In this video, strength of materials objective questions from RS Khurmi are discussed. If you like this video, please click on like and share with your friends. 1. The change in length per unit length due to load is called. Answer: strain. 2. Hooke's law is valid up to. Answer: elastic point. 3. The ratio of linear stress to linear strain is defined as. Answer: modulus of elasticity. 4. Modulus of rigidity is defined as ratio of. Answer: shear stress to shear strain. 5. The deformation of a bar of length L rigidly fixed at the upper end and hanging freely, is. Answer: WL square by 2E, where W equals weight of 1 unit volume of the bar. 6. The deformation of a bar under its own weight is. Answer: half of deformation when subjected to load equal to the weight of the body. 7. The elongation of a conical bar with length L, diameter D, and weight W per unit volume when fixed at upper end and hanging freely is. Answer: WL square by 6E. 8. Application of strain rosettes is. Answer: to measure linear strain. 9. The elongation of a circular beam which is tapered uniformly from diameter D1 to D2 when subjected to a load P, is. Answer: 4PL by pi E D1 D2. 10. The ultimate tensile stress for mild steel is. Answer: more than the ultimate compressive stress. 11. The stress generated in a rigidly fixed bar subjected to change of temperature is. Answer: thermal stress. 12. The value of thermal stress of a uniformly tapered bar with diameter small d to capital D subject to change of temperature of T, is. Answer: alpha Te small d by capital D, where alpha equals coefficient of linear expansion, E equals modulus of elasticity. 13. The linear strain of a rectangular bar of length L, width B, and thickness T when an axial pull P is applied on the bar, is. Answer: P by B into T into E. 14. The volumetric strain of a rectangular bar of length L, width B, and thickness T when an axial pull P is applied on the bar, is. Answer: epsilon into 1 minus 2 by m. Where epsilon equals linear strain, 1 by m equals Poisson's ratio. 15. The relation between Young modulus, E, and bulk modulus K is. Answer: K equals 3 into m minus 2 by me. 16. When a body is deformed in all three perpendicular direction by a stress intensity of sigma, the volumetric strain is. Answer: 3 sigma by E into 1 minus 2 by m. 17. The relation between Young modulus, E, shear modulus, G, and bulk modulus, K, is. Answer: E equals 9 kg by 3k plus G. 18. The maximum shear stress in case of direct tensile stress is occurred at. Answer: planes which are 45° and 135° to the normal section. 19. The maximum shear stress in case of direct tensile stress is. Answer: 1/2 of the maximum normal stress. 20. The radius of Moore's circle is equal to. Answer: half of difference of two principal stresses. 21. The total stored energy in a body when strained up to elastic limit is defined as. Answer: resilience. 22. The maximum stored energy in a body when strained within elastic limit is defined as. Answer: proof resilience. 23. The stored strain energy in a body when a sudden load is applied, is. Answer: 4 times when same load is applied gradually. 24. The strain energy in case of a gradually applied load is. Answer: sigma square into V by 2E. 25. The strain energy stored in a body due to shear stress is. Answer: tau square by 2G into V. 26. The point of contraflexure is a point where. Answer: bending moment changes sign. 27. For a simple supported beam carrying uniformly distributed load W per unit length, the point of contraflexure lies. Answer: at the center of beam. 28. When a beam is subjected to a bending moment, the strain in a layer is. Answer directly proportional to the distance from neutral axis. 29. A pure bending is occurred when there is. Answer constant bending moment and zero shear force. 30. The section modulus, Z, of a beam is equal to. Answer I by Y. 31. The section modulus in case of a rectangular section about its center of gravity is. Answer B d square by 6. 32. The maximum deflection of a simple supported beam of length L subjected to UDLW per unit length when applied in center of beam is. Answer 5 WL to the power 4 by 384 EI. 33. The maximum deflection of a cantilever beam of length L subjected to point load W when applied in free end of beam is. Answer WL cubed by EI. 34. The maximum deflection when a fixed beam of length L is subjected to total load W uniformly distributed is. Answer WL cubed by 384 EI. 35. The product of Young modulus E and moment of inertia I is defined as. Answer flexural rigidity. 36. The shear stress at the center of a circular section subjected to torsion is. Answer 0. 37. The torsional rigidity of a shaft is. Answer T by theta. 38. The polar moment of inertia of a solid circular shaft of diameter d is. Answer pi into d to the power 4 by 32. 39. The torsion equation is. Answer tau by r equals t by j equals g theta by l. 40. The polar modulus for a hollow shaft of outer diameter capital D and inner diameter small d is. Answer pi by 16 into, capital D to the power 4 minus small d to the power 4, by capital D. 41. When a shaft of diameter d is under a twisting moment T and a bending moment M, then equivalent bending moment ME equals to. Answer half of M plus square root of, M square plus T square. 42. When a shaft of diameter d is under a twisting moment T and a bending moment M, then equivalent. Twisting moment TE equals to. Answer square root of, M square plus T square. 43. In leaf springs the maximum bending stress developed in the plates is. Answer 3 WL by 2 NBT square. Where W equals load, L equals length, N equals number of plates, B equals width of plates and T equals thickness of plates. 44. In leaf springs the deflection at the center is. Answer 3 WL cubed by 8 NBT cube. 45. A pressure vessel is said to be thin shell when. Answer ratio of thickness to diameter is less than 1 by 10. 46. The hoop stress of a cylindrical shell of diameter d, length L, and thickness T is subjected to an internal pressure P, is. Answer PD by 2T. 47. The longitudinal stress of a cylindrical shell of diameter d, length L, and thickness T is subjected to an internal pressure P, is. Answer PD by 4T. 48. The hoop stress in case of a thin cylindrical shell is. Answer circumferential tensile stress. 49. The hoop stress in case of a cylindrical shell of diameter d. Thickness T under an internal pressure P is. Answer PD by 2T eta where eta equals efficiency. 50. If a spherical shell of diameter d and thickness T is under an internal stress P, the volumetric strain is. Answer 3 PD by 4 TE into, 1 minus 1 by M. 51. The maximum tensile stress of a thick cylinder with outer radius R1 and inner radius R2 subjected to an internal pressure P is. Answer P into R1 square plus R2 square by R1 square minus R2 square. 52. The minimum tensile stress of a thick cylinder with outer radius R1 and inner radius R2 subjected to an internal pressure P is. Answer 2P into R2 square by R1 square minus R2 square. Thank you for watching. Please subscribe the channel to get update for the upcoming video.